Today's video will explain the different symbols used to represent class relations in UML class diagrams. Hello, I'm James Helfrich. Most UML class diagrams describe a single class. It consists of the name of the class, the attributes, and the methods. Oftentimes, however, we want to represent the relation between classes, and there are many different symbols we can use. This video will explain each of these symbols and how to use them to represent real-world problems. There are several types of class relations. So first of all, we'll start with the base class, and I'm going to have a member variable called C of type composition. And we represent composition with a line, and it's always horizontal, and a filled diamond. We call that diamond the end cap, and numerosity there is 1. Now, composition means I have a member variable of type composition, and I both create and destroy that member variable. In other words, I completely own it. The second one, I have a variable called A, which is aggregation. And so I have a class called aggregation. I once again have a horizontal line, and now I'm going to have an open diamond, a diamond that's not filled, and my numerosity is also 1. Aggregation is different than composition in that I don't create or destroy the member variable. All right, I can also have a nested class, and I represent this with a pinwheel. Notice how it's also horizontal. This means the nested class is defined within the base class. Then I'm also going to have an association. An association is a horizontal line with an open arrow, not a diamond. And this means I'm going to utilize that class not as an attribute, but rather as a parameter or as a local variable. Next, I can have inheritance. Inheritance is only a line that is vertical. And here I'm going to have a triangle that is not filled. Notice that the base class is on top and the derived class is on the bottom. And the final, I have dependency. Dependency is the catch-all. It means anything else, something other than association, nested class, aggregation, composition, or inheritance. To demonstrate how this works, take a look at this class. I have a class called account. Notice I have a member variable called transaction. I have many of them. How many? Well, the star. Star means 0 to as many as I want. Since account is going to create and destroy the transaction class, then this is represented as composition, not aggregation. Notice also I have a special type of account called a check-in account. This is going to be represented by inheritance, and inheritance is going to have the vertical line. Okay, let's take a look at a very complex example. C++ has a data structure called the map, the std map. And in this class, there are a collection of related classes. Well, let's take a look at each one of them in turn. So we'll start with a class called map. Now the map is going to have a collection of methods, and notice how the map does return the iterator. So the begin, end, and find each return an iterator. Well, what's an iterator? Well, an iterator is another class, and this one is going to be by association. In other words, I don't have a member variable of type iterator, but rather I utilize an iterator, in this case as a return type. Now, iterator is actually defined within the map. It is a public nested class. UML class diagrams do not allow us to distinguish between a public nested class and a private nested class, but the iterator happens to be public. In other words, the client can instantiate a map : iterator. Okay, now I have one member variable called a BST. And this BST is going to be of type map : BST. BST, by the way, stands for binary search tree. So I'm going to have a class called BST, and there's going to be a horizontal line because it's going to be a member variable. Now, since the map is going to create and destroy a BST object, then it's going to be composition. And how many? There's exactly 1. Now, the BST is a template class, so I have a little T in the corner here, and the map has a key value template. Now, notice how the templates don't line up. So how can I turn a key value from a map into a T for a BST? And the answer is I'm going to have something called a pair. A pair is a class that has 2 template variables, K and V, for key and value. And so if I create an instance of a pair with 2 KVs, then it'll be 1 instance. Now what map does is it takes a key value pair and turn it into a BSTT, and it does this through dependency. Notice that the pair is not related to the map by composition or aggregation. It's not a nested class. It's not association, and it's not inheritance. It is something else, and that's what the dotted line means, something else. Okay, the BST is a nested class within map. It happens to be the BST is a private nested class. In other words, the client cannot create a BST object. And therefore, notice the member variable in map is map : BST to indicate that it is nested. Now, the BST is going to have a pointer to a node, and this node is going to be a B node. Well, the full name is map : BST : B node. Now, it's going to be a horizontal line because the BST has a B node, and this is going to be composition. And the reason for that is because the BST is going to create and destroy the B node. Well, how many B nodes are there? Well, it really depends on how many elements are on the map. If there's 100 elements in my map, then there's going to be 100 B nodes. Therefore, the numerosity is going to be a star. Now, the B node, it turns out, is a nested class within the BST, a private nested class, which in turn is a nested class within the map. Therefore, the fully qualified type of B node is map : BST : B node. Now, the B node has three member variables: P parent, P left, and P right, and each of these are a type B node. So therefore, it's going to point to itself by aggregation. And why aggregation? Is because if I destroy one B node, I'm not going to destroy all the ones related to it. I just have a reference to the other nodes. And there's going to be 0 to 3. 0 if I have no parent, left, or right child. 3 if I have all left, right, and parent child. Or for an example, I could be a leaf node and I only have a parent, and that would be just 1. So it's any combination of 0, 1, 2, or 3. Now the iterator, the map iterator, is going to have a single member variable called itBST, and this is of type map : BST : iterator, which means I need to have another iterator class, and the map iterator is going to have one instance of a BST iterator. Now, this BST iterator is a nested class within BST. In other words, the fully qualified name of the BST iterator is map : BST : iterator, and so we have that double nestedness going on, just like we had for the B node. Now, the iterator itself has one node called a P node, and it's going to point to a map : BST : B node, and there's going to be 0 or 1 of those. Now, am I going to create or destroy a B node from the iterator? No, I'm only going to point to it. And how many am I going to point to? Well, 0 if my iterator is the end or null iterator, and 1 if it's not, so my numerosity is going to be 0 to 1. And now we have the fully conformed class diagram for the standard template libraries map within C++. You can learn more about class relations with regards to UML class diagrams in the Class Diagrams 2 chapter of the Software Design textbook.